All right, let's just jump right in. What is the single biggest, most mind-bending puzzle in all of modern science? It's this deep, fundamental crack running right down the middle of physics. We've got two incredible theories that describe our universe, but the problem is they absolutely hate each other. See, on one side you have Einstein's masterpiece, general relativity. It paints this beautiful picture of the cosmos, planets, stars, galaxies, as a smooth, flowing, continuous fabric. But then on the other side, you've got quantum mechanics. This is the wild world of the super small, and it says reality is pixelated, jumpy, and made of discrete little packets. One is a smooth movie, the other is a choppy flipbook. And mathematically, they just don't get along. So when you boil it all down, this isn't just a physics problem. It's a deep paradox in the very language we use to describe reality. It's a clash between the math of a smooth ramp and the math of a staircase. How can the universe be both at the same time? It just doesn't make sense. But here's a crazy thought. What if this epic battle is all just one big misunderstanding? What if the universe isn't actually broken in two? What if the problem isn't with the universe, but with how we're looking at it? And this is where the theory we're exploring today flips the script. Get this. The idea is that this conflict between smooth and choppy, continuous and discrete, it's an illusion. It's a problem that comes from how we measure motion, not from how motion actually is. Okay, to really get your head around this, just picture a single dot moving in a perfect, smooth circle. No stops, no jumps, just one continuous, beautiful rotation. The theory proposes that this is what's fundamentally real. This one, uninterrupted, cyclical motion. But now, what happens when we try to measure that motion from one fixed angle? Imagine shining a light from the side and looking at its shadow on a wall. All of a sudden, that perfectly smooth circle turns into a dot, just bouncing back and forth. The continuous rotation now looks discrete. It seems to stop and change direction at each end. And boom, that's the core idea right there. You have one single motion, but it has two different faces. You've got the continuous propagation, that's the real wheel always turning. And then you have the discrete oscillation, that's the back and forth shadow we see. They aren't in conflict, they're just two different views of the exact same thing. Okay, so stick with me because this is where it gets really profound. If this simple idea is true, then maybe this single type of motion is the Lego brick that builds everything we see, from a single atom to the entire cosmos. This even changes how we think about stuff from high school math. Remember sine and cosine? You probably thought they were just abstract squiggles on a graph. Well, in this model, they're not just math anymore. They become physical. That fancy phrase, orthogonal scalar pulsations, just means they're the two different shadows of that one rotation, one from the side and one from the top, a quarter turn apart. And from here, our entire reality starts to emerge. This theory says dimensions aren't just a static grid. No, they're actively built by this motion closing in on itself. A line of motion curls up to create a 2D circle. A spinning 2D plane inflates to create a 3D sphere. The dimensions of reality are literally born from this spin. And what's wild is how this very modern physical idea perfectly maps onto something ancient, the Pythagorean tetractys. The single unified motion, that's the monad, the one. Its two opposite poles, the plus and minus, that's the dyad. The two shadows, sine and cosine, that's the triad. And the whole thing completed in 3D space, that's the tetrad. It's like this ancient wisdom was waiting for the physics to catch up. But believe it or not, that parallel with ancient philosophy isn't even the most shocking part. The real secret, the biggest no-way moment, is buried deep inside the mathematics of the theory itself.
So let me ask you, if you were to build a stable, three-dimensional system using only this one simple rule of reciprocal motion, what numbers would you expect to just pop out of the equations?
Well, it turns out the math is very specific. The absolute minimum number of components you need to make a stable 3D system is 12. You can kind of think of it as needing an in, out, up, and down for each of the three dimensions. 12 it is. Okay, so you've got your base of 12. Then, when you start resolving the system for fundamental pairings, like a particle and its antiparticle, the next number that naturally emerges from the structure is 60. And then, to complete a triadic structure, like the three components that make up fundamental particles like protons, the value you land on is 180. So, let's look at those numbers again. 12, 60, 180. Do they ring a bell? They should. These are the foundational numbers of the ancient Babylonian sexagesimal system, the very system that gave us 60 seconds in a minute, 60 minutes in an hour, and 360 degrees in a circle. And I need to be absolutely crystal clear here. Nobody put these numbers into the theory. They weren't an assumption. They just fell out of the math. They emerged directly from the pure geometry of how this motion works. It's an uncanny echo, suggesting that maybe, just maybe, the Babylonians stumbled onto the natural counting system of the universe itself. So, where does this all leave us? Could this one simple idea of rotation actually be the key that unifies the universe? Is this a whole new language for doing physics? Okay, let's pump the brakes just a little. The people behind this are very careful to say that this isn't about replacing quantum mechanics or general relativity. Those theories work. They are spectacularly good at what they do, and we're not just throwing them out. What this offers is something much more subtle, and maybe even more profound. It's a potential new foundation that both of those theories can be built upon. It's a mathematical language where that central paradox of physics, the war between the smooth and the pixelated, just dissolves. It was never a conflict that needed to be solved, but an illusion that needed to be understood. Which leaves us with one last really provocative question. For a century, we've been hunting for a theory of everything, in extra dimensions, complex string theory, and exotic particles. But could the answer have been hiding in plain sight this whole time, in the simple, elegant perfection of a single rotation?